Ladies and gentlemen, boys and girls, children of all ages, we're going to do some multiplication. And before we start, I need to say to you this. If you can multiply a one-digit number times a one-digit number, then you will always, and the rock means always, be able to be successful on multiplication no matter how big the factor is. So you could have 328,294 times 6,287,409. And as long as you know one digit by one digit, easy peasy, live goldfish squeezy. If you can multiply one digit by one digit, you can divide. This year we have to divide a two-digit number into a three- or four-digit number. If you can do that, if you can multiply by one-digit numbers, that's easy too. I just need you to start by thinking, man, I can do this. This is easy. I just got to work the process. It's a process. So I'm going to start with some three-digit numbers by one-digit number. I'm going to do two of those. And then we're going to do some two-digit by two-digit. So let's take first 116 times 3. I'm going to do some estimating here because I always like to start with estimation so that it gives me an idea of where my answer should be. If I change 116 to 120 and leave my one-digit factor the same, I can multiply 3 times 12 very easily in my head. This trailing 0, all I have to do is move it down, because 3 times 0 is going to be 0. Now I have 3 times 12, which is 36. So my answer should be somewhere close to 36, or 360. So if I do this and I don't get an answer close to 360, then I've done something incorrect. So this was my estimate. This is my estimate. Now I'm going to find the real answer. And no matter how big your factors are, you're only multiplying one digit at a time to get your final product. So I can look at my multiplication chart, or I can have it memorized. 3 times 6 is 18. Put my 8, bring up my 1. Because that means I have 18 ones. I don't want to carry around 18 ones in my pocket, so I change it for 8 ones and 1 10. 3 times 1 is 3. Plus 1 more is 4. So I have 4 10s. I can keep 4 10s, 4 $10 bills. I don't want to trade that in. So I have nothing to carry over to my hundreds. 3 times 1 is 3. And so then I get an answer of 348. So my answers are close together, which tells me I've done something correctly because I have 348 and 360. They're close together. Also, when I changed 116, I made it bigger, which means my estimate is going to be bigger than the actual product. And Maddie, I'll look in a minute. Let's look at one more. Let's look at one more. We'll go with we're going to multiply 1,825 times 7. And let me here. We're going to multiply that by 7. Now again, when I estimate, I want to do it something that's easy for me. What's easy for me might not be easy for you. So you may change one of our numbers to something else. If it's a one-digit number, I never mess with it. I leave my one-digit numbers the same. Because the more I change it, the farther off my estimate's going to be. Like for example, on this one, I'm changing this to 2,000, which is 175 bigger than this. So my answer is going to be a lot more off than if I changed it to 1800 or 1800. But I just kind of want to get an idea of what it's near. Because a lot of times if it was a multiple choice question, some of your answers would be way ridiculously too big, some would be way ridiculously too small, so you could eliminate some. Well, I know that 2,000 times 7 is 14,000. Because I can do that in my head. So now, as long as I know my one-digit multiplications, or I can look at a multiplication chart, 7 times 5 is 35. 7 times 2 is 14, plus 3 more is 17. 7 times 8 is 56, plus 1 more is 57. 7 times 1 is 7, plus 5 is 8, 9, 10, 11, 12. And so 12,775. Again, it's less than my estimate because I made this factor bigger when I estimated. Bigger when I estimated. I'm just saying. And if you can't hear me, that's because I'm muted and I'm doing this during flex time. So I didn't want to bug everybody that didn't want to hear me. So I'm just doing this during flex time and I'm not turning it on. You'll be able to watch this later. So, and although if you don't hear me, then me telling you that that's what I'm doing is not going to do you any good. So let's look at a 2-digit by a 2-digit. So now if we look at this, so you think, oh my gosh, I don't know how to do that. I don't know my 21's times table. I don't know my 73's times table. Doesn't matter. Does not matter. Okay, you're still only going to do 1 digit by 1 digit. That's it. And I'm going to do my estimation here. I'm going to make this problem 70 times 20. I have my trailing zeros here, so all I have to do is move them down. Why? Because if I did 0 and 0, these two zeros would be there, and then I did 2 times 0, which would put a 0 in the tens place. So I can just move them down. Then I just have to multiply 2 times 7, and my answer should be somewhere near 1,400. Now this is where people like to complain and say it's too hard. I can turn this into two problems. I can make it 70 times 21 and 3 times 21. That's all I'm doing, 70 times 21 and 3 times 21. Or 20 times 3 and 20 times 7. Either one of these will work because you're just breaking it apart, making it an expanded form. But I can do it like this very easily if I know my 1-digit multiplication. I know 1 times 3 is easy. I know 1 times 7 is easy. So now I'm done with my ones place. The reason the 0 goes here is because you have finished your ones place. You don't put anything in your ones place because we're now at the tens place. So this next number needs to start in the tens place. All you have to do, we're still doing 1 digit by 1 digit. You're still doing 2 times 3, which is 6. You're still doing 2 times 7, which is 14. You're just doing 1 digit by 1 digit. No matter how many digits the factors are, you're still just doing 1 digit at a time. And then you're adding those two products together. And y'all can add 13, 5, 1. Okay, so my answer is 1,533. Close to my estimate. If it were multiple choice, I'd be able to find it fairly easy. If it was, hey, which estimate would be closest, you'd be able to, it would probably be something like 1,400, with the real answer being 1,533. Let's look at another one. All right, 932 times 47. 932 times 47. This is as big as you're going to have to know here in 5th grade. As big as you're going to have to know is a 3-digit factor times a 2-digit factor. That's as big as it gets. And I could make this 900 times 50. I can put all 3 of these zeros down because that's what's going to happen if I multiply my zeros all the way through. And then I can do 9 times 5, and I get 45. So my answer should be somewhere near 45,000. Then it's just, I could do 932 times 7 and 932 times 40, because 47 is 40 plus 7. So you could do it that way and then add these two products together, but I'm going to do it just the regular algorithm. And I'm going to take my ones place through every time, a 1 digit by a 1 digit, every single time, no matter how big the problem is. So 7 times 2 is 14. I have 14 ones. I change in 10 of those for a 10. 7 times 3 is 21, plus 1 is 22. We do all of our ones placed through, and then we do the tens placed through. 7 times 9 is 63, plus 2 more is 65. But I don't know all my multiplications. Look at your multiplication chart. If you're taking an assignment or a test where you don't have one, make one. Y'all can do 1 through 9 if you're making it and counting on your toes. I don't care. Now I'm done with my ones place, so I don't want to put anything in my ones place. So I put that there to make sure I don't put any other number in my ones place. So now I go my 4, because I'm in my tens place. My first number has to be put in my tens place. 4 times 2 is 8. I'm done with these. 4 times 3 is 12, and I carry the 1. 4 times 9 is 36, plus 1 is 37. And then I just add these two products together. 4 plus 0 is 4, 2 plus 8 is 10, carry the 1. 5 plus 2 is 7, plus 1 is 8. 6 plus 7 is 13. So I got 43,804. So, close to my estimation. And that's as easy as it gets. Please, for the love of Pete, keep in your head that you will be great at this. Because if you keep that in your head, you will be great at this. Pretty soon, you'll be teaching your mom and your dad and the lady at the grocery store and the guy at the park and the little boy that you're pushing on the swing. You'll be teaching them all these things. Because the bottom line is, you're a genius. And you're just going to become geniusier.